Hello everybody, my name is Kiran. I am working as an assistant professor on the department of EEE Anits. I welcome you all to my third lecture on the first module DC generators. So in my first lecture I discussed what are the construction details of DC generator, and in the second lecture we have seen the working of DC generator and how a commutator is playing a crucial role in the working of DC generator. In today's lecture we are going to see or derive the EMF equation of a DC generator. So let us assume that phi is the flux per pole in Weber, Z be the total number of conductors, which will be equal to the number of slots into the number of conductors per slot. Let capital P be the number of poles. Let capital A be the number of parallel paths. As we have discussed earlier, in case of lap winding it is equal to number of poles. In case of wave winding its value is equal to 2. Let capital N be the speed of armature in revolutions per minute RPM. Let EG be the total generated EMF in DC generator. So now EMF generated in one conductor can be expressed as Eg small e suffix g is equal to flux cut by a conductor in one revolution divided by time taken for one complete revolution. Okay, since we already have, so here in the first statement itself we assume that let phi be the flux per pole. So each pole is producing 5 Weber's flux. So how many total flux that is cut by a conductor can happen in one complete revolution? P into phi, because P is the total number of poles, phi is the flux cut by a single pole. So how many poles we have? P poles. So what will be the total flux cut by a conductor in one complete revolution, which is nothing but P into phi. So in 60 seconds, as we have also assumed, N be the speed of armature in RPM, revolutions per minute. So it means that in 60 seconds it can complete N revolutions. So what is the time taken for one revolution? Will be nothing but 60 by N seconds. So substituting that in my expression, small eg is equal to P phi divided by 60 by N, which will give me P phi N by 60. But we actually need what is generated EMF of the entire DC generator. That is nothing but generated EMF of one single conductor into total number of conductors connected in series per parallel path. This we already know. This is P phi N by 60 is one single conductor, EMF generated in one single conductor. How many such conductors I have? Z. And in how many parallel paths I have? A. So my total expression for EMF equation of a DC generator will be P phi N by 60 into Z by A. So this concludes my today's lecture on the EMF equation of DC generator. So until we meet with another topic in the next lecture, take care. Thank you. Goodbye.